Alrighty, folks, we are ready to get started. So this is the study guide for your final, which is coming up tomorrow for some of you, on Monday next week for most of you. So I just want to go over the study guide as it is right now and go through every solution. So feel free to skip around the video because I will be going through every single problem that's on this study guide. So that includes the graphs, that includes the composite figures down here. So yeah, skip around until you get to a spot where you feel like you need the most help. So getting started, I just want to bring your attention to the very top of the page. It lists a lot of different polygons. It also lists some formulas that are going to be very helpful for you. So let me zoom in just a little bit more here. We have the interior angle sum of any polygon, 180 times n minus 2. N, remember, is the number of sides. So let me write that down. N is the number of sides. So keep that in mind. Same thing for the angle of a regular polygon. Just one angle of a regular polygon is taking this same formula, but then dividing by the number of sides once you get that number. Exterior angle sum is always 360, and then following the same pattern, one angle is 360 divided by the number of sides. Then here we have some area formulas for rectangle, circle, triangle, and circumference of a circle. So with that in mind, let's get started on some polygons. First, we're going to find the sum of interior angles of a regular nonagon. So a nonagon, we have to remember that a nonagon contains 9 sides. So because it has 9 sides, we're going to plug that into the n in our formula. So the formula becomes 180 times 9 minus 2. And when we type that into our calculator, I'm actually going to use my phone. Luckily, I know what this one is off the top of my head. It's 1,260 degrees. So that is the answer to part A. Part B, one interior angle. Remember, we're taking this formula right here, and just dividing by the number of sides. So I already have this number, 1260. I'm going to take 1260 and I'm going to divide by 9, the number of sides. That gives us 140. Whoops. So let me do 1260 divided by 9. That is 140, and that is my answer. So one exterior angle now. We're looking at the outside. So if we had angles on the outside of that nonagon, what is that sum going to be? What is one exterior angle going to be? Sorry. We know that the sum is 360, so one angle is 360 divided by 9. So 360 divided by 9, that is 40 degrees. So 40 degrees is our answer for that one. Okay, so moving on, we're going to solve for x for this shape here. Now, it doesn't really matter how many sides it has. I could count up the sides, but it doesn't matter because the angles are on the outside. And no matter how many sides it has, that sum will always be 360. So if I added 3x plus 70 plus 2x plus 65 plus 75, that's going to be 360. So I can use that to set up an equation. That's going to be really helpful for me. Let me go ahead and take a shortcut on that equation here. So I'm going to add 70, 65, and 75. That gives me 210. So I'm going to start my answer with 210 plus. Now I'm looking at the x's. There's a 2x and a 3x. So that is 5x. I can do that in my head. And like I said, that's going to equal 360 degrees. So now we have a simple equation where we can solve for x. We'll just do inverse operations. Subtract 210 from both sides of the equation. They have to be on opposite sides of that equal sign. 5x equals 150 degrees. So then I can divide by 5 to get x by itself, and now I have x by itself equals our answer, 30 degrees. So that's how we solve for x. I'm going to take these off because they're bothering me. Okay, So we're done with exterior angles, at least for this particular shape. Next, we have some interior angles. Now this time the number of sides does matter because that's going to tell me what I'm going to plug into our formula up here. So let's count the number of sides. There's 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. I mean, this is an octagon. So octagon, yeah, regular octagon looks like this. But as long as the shape has 8 sides, it is an octagon. So we're going to take the number of sides here and plug it into our formula to get what the interior angle sum is going to be of this octagon. So we'll kind of quickly do that up here. That's going to be 180 times 8 minus 2. Plugging that into the calculator gives us 1080 degrees. So that's our sum. That means all of these angles added up equals 1080 degrees. So I can use that fact to solve for x there. I'm going to do x plus, using my calculator to add up all of the numbers here. We have 164 plus 104 plus 96 plus 176 plus 135 plus 145 plus 97. So that's 917 equals 1080. So again, just subtracting 917 from both sides. X is 163 degrees. Great. So moving on again. Here we have some funky looking shape that we haven't really seen before. But if you look closely, you can see that all of these angles lie on a straight line right here. That means they're supplementary. So because they're supplementary, their sum is 180 degrees. Straight line, 180 degrees. So then I can add these up together. 24 plus 4x minus 34 plus 40 plus x is 180 degrees. So I'm going to keep my work up here in the top corner, but I'm going to add all of these numbers just like I've done before. So let me get rid of this. I don't need it. Okay. So 24 plus 40. Oh, wait. Yes, plus 40 minus 34. That gives me 30. So 30 plus, now I'm going to look at my x's. I have 4x and then I have 1x. So that's 5x. And that equals 180. Subtracting 30 from both sides gives me 5x equal to 150. And I did that in the last problem up here, so I know what that's going to be without using my calculator. X is 30 degrees again. So there, we've done that problem. Not too bad. As long as you can see the supplementary angle relationship, you're good to go. And you can solve this problem. No problem. Anyway, so let's move on to this one right here. We have a triangle. And we know, due to the triangle angle sum theorem, that all of these guys are going to equal 180. We also know that because of our work with polygons, right? So here, we don't know what this guy is. We have to figure out what this guy is first before we go using the 180 formula, because we already have a variable in here. And that means because this is x, I cannot call this x. I'm going to have to call it something different like y, and then I have two variables, and that's just too much work. So I can use this guy right here to help me find what this angle is. The way that I can do that is by knowing supplementary relationship here. 180 minus 105 is going to give me this leftover angle right here. So again, I can do that in my head. That is 75 degrees. So now we have this angle, and now we have all of these guys. We can set them equal to 180. So just in my head real quick, 34 plus 5 is 39. 39 plus 75 is, I don't know, 39 plus 75 is 114. So 114 plus how many x's? Just 1 equals 180. So now this is just a simple subtraction problem. X is 66 degrees. I believe that's correct. I did a little too much math in my head that I'm not super confident on, but the steps that I've done are correct. So check the solution guide that I posted on Google Classroom because that one is definitely correct. Okay, so here, there's two ways to solve this problem. We can see that this is a 90-degree angle. So, two things. One, we can notice that because this is a 90-degree angle, we know that this is a 90-degree angle, right? So that means this guy right here, whatever this angle is, it doesn't say 90, but we know that it's equal to 90 degrees. So if we did 2x minus 12 equals 90, that is a valid equation that we can use to solve for x. We'll get the same answer if we do it this way, or if we do it another way, which is by, again, noticing a supplementary relationship. This plus 90 is 180. That's a little bit extra step, but that might be the first thing that you think of right away. So we're going to do this way because it's shorter. We're going to add 12 to both sides. 2x equals 102. So dividing by 2, half of 102 is 51. And just like that, we are done with the first page of the study guide, and we are only 11 minutes in. Man, that's actually pretty long for a video. No worries. We're going to move on to the back side. We have systems of equations that we can choose methods to use to solve for. Unfortunately, a lot of these have fractions. Two of these, I think the first one and the third one, involve fractions as our answers. But that's okay. That's totally fine. I'm going to show you what we're going to do with that. So let's start with this one. Let me zoom in a little bit more, just so you can see the work that I do. So we have we have y equals 4x plus 2 and y equals negative 7x plus 11. These expressions right here, they both equal y. They have equal values, so we're going to set them equal to each other. It's going to look like 4x plus 2 equals negative 7x plus 11. So doing some quick math here, let me switch pens so that it doesn't get too confusing. I'm going to subtract 2 from both sides. I'm writing it under the 11 because that's what I can combine it with. I can't put the 2 to the 7x because that has an x, and that does not. So similarly, if I'm going to add 7x on both sides, I'm going to make sure I stick with the numbers that have x's. So these cancel, these cancel. 4 plus 7 is 11, so 11x equals 11 minus 2 is 9. See, like I said, this is our first fraction, so x is 9/11. That's the first part done. Now we can use x being 9/11 to plug back into our easier looking equation and solve for y. So I'm going to do that in green. Y is going to be equal to 4 times 9/11 plus 2. So y is 36/11 plus 2. That is, okay, apologies for that. I accidentally ended the recording, but we're going to keep going. So 36/11 plus 2 is, of course, 5 3/11. I believe, let me see. That comes out to be something. I don't remember what it was in the solution guide, but I'm going to write it as that kind of fraction. It's about 5.27. So 5 3/11. Therefore, our solution is 9/11, comma. I'm going to put the fraction. I'm sorry, the decimal. Apologies. I'm out of it. Okay. So there's our solution. 9/11, comma, 5.27. I think moving forward, I'm going to stick to the decimal values just because it's a little bit easier for me to get at the moment. But the fractions that are in the solution guide are perfectly fine, just as valid. All right, so here we should get a whole number as our answer. We have x equals negative 3y plus 1. And then we have y plus 7x equals negative 13. I know it's a little blurry right now. Don't know why that is. Since we have an x value, x equals something, we can use that and substitute any x that we see with the value that it is. So it's going to look like y plus 7 negative 3y plus 1 equals negative 13. Now it's just distributing, combining like terms, and moving stuff over so that we can get y by itself. Okay, so these two y's go together. Y minus 21y is negative 20y. In the same step, I'm going to subtract 7 on both sides just to save some space. So negative 20y equals negative 20. The solution is obvious, but I'm going to go ahead and divide 20 just to make it more clear. Negative divided by a negative gives us a positive, and the same number divided by itself is 1. So y is 1. Keep that in mind. We're used to getting our x value first, like we did for the first problem, and then plugging it in for x, but we got our y value, so don't make that mistake. We have our y value, so I'm going to plug it into the y. Do it in a different color. X is negative 3 times 1 plus 1. So negative 3 plus 1 is negative 2. So our solution is negative 2 comma 1. And that's it for the second problem here, the second system. We're moving on to the third. We have a system that looks to be perfectly set up for elimination. So we're going to do that. Treat it as one giant problem where you're combining like terms from top to bottom. So negative 4x minus 8x, well, that's negative 12x. It looks like the y's cancel, which is really nice. That's exactly what we want in an elimination problem. So 20 plus 20 is 40. Now we have to divide, and this is why we get a fraction again. So 40 divided by negative 12, like I said, going to use the decimal value. Okay, 3.33 repeating. That's a negative 3.33 repeating. So that's our x value. Let's move on to the y. I'm going to take that x and plug it into one of these guys. Maybe the top one. Looks a little bit more simple to me. So negative 4, negative 3.33, plus 2y is 20. This is going to be, let's see, 3.33 times 4 is 13.33, blah, 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 plus 2y is 20. So I'm going to subtract this guy, move it over, get y by itself. Running out of room here. That will be 6.6 repeating, whatever. Divide by 2, boom, y is 3.3 repeating. So there's our solution. Negative 3.33 repeating and 3.33 repeating. I don't, unfortunately, have space to write the coordinate for that, but remember the x goes first, so the negative 3.33, and then the y, positive 3.33. Okay, moving on to our last system using algebra. We have, again, an elimination problem. However, and I can tell it's elimination because of the way that this is set up. Both x's and y's are in the same spot, same side of the equal sign. So I'm going to multiply this one by 2 so that I can get this 2y to equal 4y. Then it's going to cancel out with that negative 4y, and then we have ourselves an elimination problem. But something interesting happens here in this particular elimination problem. So this bottom one here is our new equation, right? We can kind of ignore this top one because I multiplied every number by 2. Now we have 8x plus 4y equals 22. So the x's cancel and the y's cancel. So that's 0 on this side. And then on the other side, 23 plus 22 is 55. I mean, it doesn't matter because 0 does not equal 55, right? That actually means there are no real solutions. There are complex solutions, but we will not get into that. So no real solutions because 0 does not equal 55. All right, we're going to move on to graphing some systems. This is pretty straightforward. We just need 2 pieces of information for each line. We need the slope and we need the y-intercept. Both of them can be found by looking at the equations. So the slope is going to be the value that has x, the coefficient in front of the x. So in this case, it's 2 over 3. The y-intercept is going to be the other number, so 4. We'll start with the y-intercept. We'll start at the origin, 0, 0, exactly in the middle, and go up 4 spaces for the y-intercept. So that's right there, I think. Yes. And then our slope says go up to right 3, always to the right, up to right 3. And I'll keep repeating that until I get some dots to connect. I can go down to left 3, which is the exact opposite, and then I get a line, boom, perfectly straight, straight as a dollar. For the next line, y-intercept is positive 4 again. Okay, so we actually really don't even have to do more work because we already have a point of intersection. But I'm going to go ahead and draw what the line would look like anyway. But here you can see this is where the two lines intersect by going up 4 spaces. So that is 0, 4. All right, second equation here. We have y minus 4x. Oh, got to fix that. Let's move this negative 4x over here so that it looks like y equals mx plus b, right? So if I do that, y is 4x plus 10. Wait, 4x plus 10? 4x plus 10, that's the same line, okay? Here's our y-intercept. Our slope is like that. So if I were to draw the other equation, it would look exactly the same. Therefore, because these lines are exactly the same as each other, there are infinitely many solutions. These lines, since they go on forever, they will have solutions forever. Okay, so looking at this one, you can see a very similar thing happening, but also a little bit different. Up here, our equation y equals x plus 7. The bottom one, y equals x minus 2. So the slopes are the same again, but the y-intercepts are a little bit different. This looks like 7, I don't know. And then this line is, the slope is x, so it'll look like that. The second one, negative 2 is our y-intercept. The slope is also x, so it'll look like that. Oh snap, these lines are parallel. They will forever go in the same exact direction, but since they're so far apart from each other, they will never intersect. Therefore, there are no, real solutions. So, lastly, we're going to talk about some composite figures. Now we have, let me switch papers. This is looking a little crusty over here. Okay, so we have two composite figures. Let's look at the first one. First one here is made up of what looks like some rectangles. If I were to kind of section off these rectangles, matter of fact, let's do it this way. Let's just connect that line and make one big rectangle instead of 3 smaller ones. Now I have a big rectangle that goes like this, and then I have a little rectangle that goes like this. So instead of adding the areas together, I can take the area of the big rectangle and then just subtract the area of this little rectangle right here. So let's go ahead and do that. That's going to save us a step. The area of the big rectangle depends on the length and the width, or the length and the height. So the length is 30, and it looks like the height is 15 millimeters. So the area of the rectangle is going to be 30 times 15. Quickly doing that in the calculator. 30 times 15 is 450. So that is 450 square millimeters. Then moving on to the little guy, 8 times 10, that's 80. I don't even have to use the calculator, so I'm going to subtract these. 450 minus 80 gives us an area of 370 square millimeters. And then for perimeter, I have to look at the shape that we have, not the fake rectangles that I've kind of made. So I'm going to go back to this one right here. I have to take this side, that's 30, plus 15, plus whatever this is, plus 10, plus 8, plus another 10, plus whatever that is, plus 15. So that's 8 sides total that we have to add up. There are 8 numbers that we need to add together in order to get our answer for perimeter. So finding these 2 sides is not too bad. We know the entire bottom, therefore the entire top is 30. We know that there's this 8 millimeter chunk taken away from it, so that means it's 22. But where is the 22? It's between this guy and this guy. So if we divide 22 by 2, we get 11 here and 11 here because it looks like they're exactly the same size. So they are half of 22 each. So 11, 11. Therefore, our perimeter is 30 plus 15 plus 11 plus 10 plus 8 plus another 10 plus another 11 plus finally the last 15 to get our perimeter, which is, God, I don't know. Hold on. Okay. 30 plus 15 plus 11 plus 10 plus 8 plus 10 plus 11 plus 15. That's 110 millimeters. Okay. So let's finally move on to the circle, the half circle / triangle thing, rectangle, misspoke. Okay, 8 centimeters, 5 centimeters. Area of that's pretty easy. That is 40. So now I just need to find the area of this half circle here. Area of a circle, if you go back to the front of your study guide, is given to us. Wow, very hard to see. Pi r squared. A is pi r squared. That means pi, the number pi, times the radius, which we can find out pretty easily here. Radius is going to be, let's see, if the diameter is 5, right, the entire length of the circle is 5, the radius is half of that. So half of 5 is 2.5. So r is 2.5. I'm going to make a note of that. And then we have to multiply that by pi, and then square the radius. And then, since this is half of a circle, we have to divide our answer by 2. So that won't be too bad. 2.5, okay, let me write that. So area of a circle is pi times the radius squared, and then we have to divide that by 2. So that's going to be 2.5 squared is 6.25 pi divided by 2. So the area of our circle becomes, handy dandy calculator, 6.25 divided by 2 is 3.125. I'm going to round that up to 3.13 pi centimeters squared. So that's our area of the little half circle. That means the combined area is going to be these two values added together. So 40 centimeters squared plus 3.13 pi centimeters squared. The pi, even though it's a constant, means that we can't add it to the 40 here. So we'll leave it as is. Now the perimeter, switching again, perimeter involves finding the circumference of a circle. And since it's only half of a circle, we're going to find the circumference of a half circle. So circumference of a circle, you can find that on the other side of the study guide again. That is 2 pi r. But since we're cutting that in half, it's just pi r. So the circumference of our little circle is going to be pi times our radius, 2.5. So there we go. We'll just move the pi to the other side, but we'll do that once we write down our answer for perimeter. Here, we're going to add 8, 5, and 8 again. So 8 plus 5 plus 8, let's see, that is 16, that's 21. So just like that, our perimeter is 21 centimeters plus 2.5 pi centimeters. And that is our answer. So that is it for the study guide. I know it was pretty long, but you can skip to any problem. You can speed up the video, you can slow it down, you can pause it, you can ask me any last minute questions tomorrow, and you should all be good to go. So that is it for the night. I hope you all have a great study session and stay Gucci.